Imagine a world where computers can solve problems in seconds that would take today's fastest supercomputers thousands of years. Welcome to the realm of quantum computing, where the impossible becomes possible. Unlike classical computers, which use bits, quantum computers use qubits. This fundamental difference allows them to process information in ways we are only beginning to understand, opening doors to unimaginable possibilities. Qubits are the heart of quantum computing. Unlike bits, which are either 0 or 1, qubits can be both at the same time, thanks to superposition. This unique trait allows quantum computers to handle complex calculations efficiently. Entanglement is another fascinating property of qubits. When qubits become entangled, the state of one instantly influences the other, no matter the distance. This interconnectedness is key to quantum computing's power. Classical computers, like the one you're using now, process information sequentially. Quantum computers, however, can perform many calculations simultaneously, thanks to their unique properties. This makes them incredibly powerful for specific tasks. While classical computers struggle with certain problems, quantum computers excel. For example, they can factor large numbers exponentially faster, a task that would take classical computers an impractical amount of time. Quantum algorithms are the secret sauce behind quantum computing's magic. They leverage the unique properties of qubits to solve problems that are currently unsolvable by classical means, like simulating complex molecules. Imagine predicting chemical reactions with pinpoint accuracy or optimizing complex systems in real time. Quantum computers hold the potential to revolutionize fields like chemistry, logistics, and cryptography. Quantum computing's potential applications are vast. In medicine, they could lead to breakthroughs in drug discovery. In finance, they might optimize trading strategies. The possibilities are as limitless as our imagination. Industries worldwide are investing in quantum research, anticipating a future where these computers transform how we solve problems. The impact could be as significant as the invention of the internet. Quantum computing is surrounded by both excitement and skepticism. While the potential is enormous, challenges like error rates and scalability remain. The journey to practical quantum computers is still unfolding. Despite the hurdles, the race to quantum supremacy is on. Companies and governments are investing heavily, hoping to unlock the next technological revolution. The timeline for widespread adoption is uncertain, but the excitement is palpable. You've embarked on a journey through the fascinating world of quantum computing. As this field evolves, staying informed will be key. Follow developments, read articles, and engage with communities to deepen your understanding. Consider exploring online courses or attending seminars to expand your knowledge. Quantum computing is a frontier of innovation, and your curiosity can lead to exciting opportunities in this emerging field. By understanding quantum computing, you're preparing for a future where these machines could redefine our world. Embrace the challenge and let your curiosity guide you through this quantum journey. Take the next step in your quantum adventure. Dive deeper into the subject, share your insights with others, and contribute to the conversation. Together, we can unlock the mysteries of quantum computing.